ICND1 Review Lab, Step 7, Network Address Translation. I am having a blast going through this lab, and I hope you are too. We are rounding out the final 2 steps, and that's probably good because I think I get more giddy the further I go through this lab. We're now into the Network Address Translation. Configure NAT on router 1 in such a way that all the users of the corporate office can access the internet by sharing the public IP address assigned to router 1. Note, only valid IP addresses from the corporate office should be permitted to use NAT. Router 1 should NAT only IP subnets shown in the network diagram. That's a little bit tricky. We're going to have to come back to that. Okay. Verify NAT is working correctly by pinging 4222 or 8888 from PCA or PCB. Note, if building this lab on your own, you'll need to configure these IP addresses as loopback interfaces on the ISP. We actually did that early on in this lab when we did the IP addressing in GNS3. Do not configure any other routes on the ISP. If NAT is working correctly, the ISP should be able to respond to devices behind router 1. Now, a couple things of note that I want to discuss. I said, ooh, this is going to be a little tricky. It says it should NAT only IP subnets shown in the network diagram. Shoop. Now, that's tricky because we might look and go, okay, all these corporate subnets, but it distinctly said, shoop, that we should only be NATing from the corporate office. And then it says to test it using PCA or PCB. If I were doing a simulation on an exam, I would say that probably means I am not going to include the branch office in this NAT magic that we're about to set up. But that does include all of the VLANs in the corporate office. Let's do it. The first step in configuring NAT is to label your inside and outside interfaces. From router 1's perspective, this interface, serial, well, in the diagram shows 0/0, but in our GNS3 world ends up being 1/0, will be the outside interface. The inside interface, and you can't miss this, will be fast Ethernet 0/0 and any sub interfaces that you are using, for example, to do router on a stick. So let's hop on over to router 1 and we'll get logged into this router. Show IP interface brief. It's always good to have that staring you in the face when you're doing the configuration. Global config mode, interface serial 1/0, outside interface, IP NAT outside. Label that. Now it always hangs. Don't let that freak you out. Well, okay, let that freak you out. Looks like I've hit another GNS3 error here, NBAR error, insufficient dynamic memory. That I'm gonna keep going. Let's just do a quick show run interface serial 1/0. Yeah, that's not good. Let's try rebooting this guy. Just keeping it real here. Sometimes working with the simulator lands you in a tough spot. So let's bring this guy back up, start his engines one more time. Now you can see why I often say use real equipment, because a lot of your time could end up being spent troubleshooting issues with an emulator rather than learning Cisco content. And I know. The reason I chose GNS3 to do this is because worldwide, not everybody can afford a rack of equipment with 3 or 4 routers and 3 or 4 switches. Totally get that. That's why we're here. Let's do a show run interface serial 1/0 now. See if we are alive and well. Let's see if we can do that NAT command again without something blowing up. IP NAT outside. Yeah, that's not good. Google, will you rescue me? Just so you know, all I do when I run into issues like this is I go to Google. Here, let me shrink this down just so you can see you can see what I do. I just copy and paste. I type GNS3 in the first line of the error, and usually somebody has run into the issue like that. And what this guy is saying is you need some more memory on your router. So let's go to our router 1. Let's do what they're telling us to do. We'll stop router 1, down, configure, click on that, memory and disk, and we'll crank this guy up to 256 megabytes of memory. Okay, and power him back on. There we go. Let router 1 load back up right now. Looks like there's some more memory there for us to use. Log in, and let's try it one more time. Interface serial 1/0, IP NAT outside. Gritting my teeth. Oh, that's great. I held my breath. There's a lot of time I just edited out right there where it's just kind of hanging there. That's normal because turning on NAT does take some processing power. And once again, GNS3 has saved the day, or I should say Google has saved the day for GNS3. Now let's get those interfaces back up in front of us. Show IP interface brief. We'll go into, I lost all of my config. There we go, just more chance to practice, right? Do show IP interface brief, and we should now see those interfaces restored. Good. Interface fast Ethernet 0/0 IPNAT inside fast Ethernet 0/0.2 NAT inside and .5 NAT inside. We need to label not only the VLAN 1 interface, but also the sub interfaces connecting to IT and accounting. Second step of NAT configuration after I've labeled the inside and outside interfaces is to create an access list which identifies what traffic should be NATed out. So looking at this list, it says only addresses from the corporate office will be permitted to use NAT. And that was very purposeful with the way that statement was said. So we need to go up there and say, okay, what subnets exist at the corporate office? 1024.0.0, that guy right there. 1024.5.0 and 1024.2.0. All those subnets should be allowed to NAT. This guy and this guy we won't include. Not part of the corporate office. Now to identify them. We'll exit out of the subinterface configuration mode and let's do a standard access list. I'm going to use a named access list. So we'll do IP access list standard and let's just call it NATable. They just pop into my head. So I'm going to say permit the address 10. Let's look at the subnets 1024.0, 5, and 2. So we'll come back here 1024.0.0 with a wildcard mask 0.0.0.255, which says match everything starting with 10. 24 is the second octet, 0 is the third octet, and then I don't care what comes after that. It's valid for NAT if those first 3 octets exist. Hit the up arrow and we'll do it for the IT VLAN and we'll do it for the accounting VLAN. So now we've got a access list that should have the 3 subnets in it. You can see the 3 different sequence numbers, 10, 20, and 30, that are allowed to be NATed. Step 2 is done. The last step of NAT is to type in the NAT command that combines it all together. That says, here's the addresses that I'm NATing, here's where they're going to be NATed to, and I want to overload it, meaning enable dynamic NAT or NAT overload, depending on which vendor's verbiage you're using, to share a single public IP address amongst all these private subnets. Here's the syntax. IP NAT, and we're going to say, I'm going to NAT from the inside of our network the source addresses defined in access list NATable. Hang on, that was fast. Let me slow down and stop right there. I want to NAT from the inside of my network out, and the inside of my network is defined by IP source addresses identified with access list NATable, referring back to the 3 subnets that we typed in there. We could also do static one-to-one mappings, or if you're a CCNP or CCIE guru, you would jump into the route map world, which is really a miniature programming language for Cisco routers. We're not going there. We're sticking with the access list. So it's saying, okay, those are the source addresses, and I want to send them out. I'm going to say, in this case, the interface. You could create a pool of addresses, but when you only have one address, like .173 there, there's no reason to create the pool. So we'll just say, send them out the interface serial 1/0, but don't forget this, overload it. Otherwise, you'll get one IP address that translates out, and then you've used up your outside address. Overload allows it to use port address translation, or what Cisco calls NAT overload, to share that one IP address amongst all those subnets. Now the last thing we need to do is test. The lab said that these devices should be able to ping 4222 and 8888 from PCA or PCB. Let's give it a try. I'm going to go over here to PCA, who should still have the IP address dynamically assigned, although I didn't check it until after router A or router 1 crashed. There we go. IP address is still there. I'm going to do a ping 1024.2.1 just to make sure we are reaching our default gateway and life is good. Good. Now let's do a ping to 4.2.2.2. Successful. That's fantastic. I'm going to ping 8.8.8.8 as well. Successful. We should be able to hop on over to router 1, do a show IPNAT translations. Oh, that's so good. And see the ping messages that are being translated. You can see there's the source address, there's the destination address, and there's the what's known as the inside global, the public address that we're using post-translation. Let's hop on over to PCB and make sure that we have some success there. Ping 4.2.2.2. Little longer of a pause there, but it got through. And 8.8.8.8. Those pauses don't normally happen on real gear. That's likely just a GNS3 lag because it's having to do some work to do NAT. Hop back up to router 1, hit the up arrow, show IP NAT translations. Oh, it's already timed out the other ones. The 2 is gone and out. ICMP translations are short. We see our accounting PC going out, reaching those different IP addresses. We are looking good. NAT translation is in place. We've only got one more step left. We'll take that out in the upcoming nugget. I hope this has been informative for you, and I'd like to thank you for viewing.